Welcome, everyone. I'm very excited to share how MongoDB is using Cedar to power their fine-grained authorization. My name is Neha, and I am an applied science director at AWS, where I lead efforts to apply automated reasoning and formal methods to create secure and scalable authorization systems, among many other things. And it's my great privilege and honor to be speaking today with Jim Scharf, who is the CTO of MongoDB. Jim has deep expertise in a lot of things, including authorization, distributed systems, databases, and has had a lot of experience running large systems at scale. So I want to take a moment and say, authorization is all around you. Authorization is also on you. It's the badge you're wearing. And one of the things you'll notice about the badge you're wearing is the color is not the same for everyone. Different people have different color badges. The colors are part of an authorization system that we use at Inforce. Orange badges are for AWS employees like me, which gives me access to staff areas. Gray badges, like the one Jim has, are for executives who are customers. It does get him into some really nice lounges. And others, like a lot of our customers have black badges. Red is for press, that gives them access to briefing areas, press and analyst review areas. And sponsors and partners have their own badge colors. And this simple example can show how authorization is so omnipresent in our lives. But it goes deeper than color. Not every customer can access every session. A lot of you got access to this session because you registered for this session. And that is the notion of fine-grained access management. And of course, authorization isn't just about conference badges. It's present in our everyday lives. When you go home, you take out a key and get inside your front door. That is authorization. You go into your workplace. You take your work badge, scan it, get in. That is authorization. When you travel, when you walk up to immigration and show your passport to board a flight, that is authorization. And that is also present in all the software that we build every day. And authorization is crucial for security and compliance. And today, we will explore how Cedar helps us manage these authorization decisions at scale, and specifically how MongoDB has implemented it for fine-grained access control. Cedar was AWS's answer for authorization at scale for your applications. And let me paint a picture here. You have a simple banking application, a few hundred users, a few thousand permissions. That sounds very manageable. But then, if you're a US bank and you want to expand to Europe and Asia, suddenly you're dealing with hundreds of users, thousands of applications, millions of permissions, and very complex regulatory requirements. And now you have to have a different mobile app. One for iOS, one for Android. Your permissions are scattered across a dozen code bases, possibly dozens of programming languages. And that is where the homegrown authorization systems often break down. We built Cedar, a way to define authorization as code that is separate from your application code. And Cedar is designed with security-first principles. It scales as your application and your business needs scale. So let's look at Cedar with some real policy examples. And these three policies, the goal is to show what the power and the ease of which you can do these use cases with Cedar. The first policy is really simple. Here it says everyone can attend lunch and the expo. It has no complex condition. Just straightforward access. The second policy shows any customer can register for sessions. And finally, we have speakers like myself and Jim who can access the speaker ready room. If you take a moment to notice these policies, they are pretty readable. They're not just machine executable, but they are human readable. This was a key feature as we thought about the design when looking at Cedar. It's also crucial for security administrators like you who need to review and audit permissions. It becomes a self-documenting artifact. Anybody who can read the policies can understand what the policies are doing. Now, if we expand this to fine-grained authorization, what does that mean? Let's take a look. We have this policy that says customers can attend sessions, which is very similar to our previous policy, but it has an additional when clause. The policy only permits access when the customer is part of the session's registered attendees. But here it's not enough to say you are a customer, so you can attend a session. You have to be specifically registered for the session to attend it. That is fine-grained authorization in action. Now, this is a particularly powerful example because it combines both role-based access control, you being a customer, that's your role, with attribute-based access control, being registered for that specific session being the attribute. And Cedar makes it very easy to express these complex relationships in a very clear and maintainable way. Let's take another look at another example. This policy controls access to the expo area predicated on the when clause, and it checks if the current time is within the expo's operating hours. It checks is the current time between the opening and the closing. This is giving you a flavor of the types of things you can have your policy check and do. And you can extend it for every sponsor. If you're a sponsor, you may need access for extended hours. You may need to set up your booth, take it down. This has to be outside the expo hours. So the organizationers can say, hey, let's create a policy so that the sponsors can get access 2 hours before the expo opens, and they can stay 2 hours later after the expo is closed, so they can take down their stuff, secure their area, and make sure they have everything that they need. How are people doing it today? I've talked a lot about these Cedar policy examples, but I haven't talked about what people are doing today. If you look at how application code is written in Java or Python, you can have, for the iOS app, you have to recreate that same permissions. If you're writing them in application code, you'd have to do it in the same permissions model, now in Swift, because your iOS app is written in Swift. And what ends up happening is that the application code gets intermixed with the permission code. And it makes it hard to know, hey, where are the sponsors? Who have I given access to? If I want to now change sponsors having 3 hours access instead of 2 hours additional access, I'd have to go change code in multiple different applications. I'd have to go change some Java code, some Python code, some Swift code. And I'd also have to check that they don't get out of sync. Which am I deploying first? Oh, that's another thing. I have to deploy code to ensure that my permissions are actually spread across these things. But if you're using Cedar, you have a very clean separation. You have a clean separation between your application code and your policy code. They are declarative. They are separate from your application. They're easy to review, easy to audit, and it ensures that there is consistent enforcement. And you don't need to do code deployments to have policies. As I said, we've built Cedar for your applications. But I also want to talk about how we are using Cedar internally at Amazon. AWS Verified Access provides you zero trust access to your enterprise application. With Cedar, it uses Cedar, it even exposes Cedar to end customers. You can specify access based on who is the user, whether their device is compliant, what time of day it is, what is the location that the request is coming from. So even if it's an enterprise app that's not on the VPN, You may say, oh, it's okay if you're coming from a location within the US. But oh, if you're coming from a location that I don't recognize, then access is denied. Cedar provides this ability for applications to help users do that. Now, we talked about authorization being needed everywhere on Earth, but authorization is also needed by satellites that are running in space. And this one's a particular favorite of mine. Project Kuiper is sending satellites in space, and they are using Cedar. And it's a very vanilla use case. It's saying, hey, the agent needs to restrict what it can see and what it cannot see based on the business tier it's part of. Very straightforward authorization request. It goes to our story that authorization is indeed everywhere around us. There's dozens of internal applications that are using Cedar. They're doing it through Amazon Verified Permissions, which I'm going to come to a little later. It's our managed Cedar offering. But if you look at these examples that are using Cedar, there's probably similar applications for your company. All of the companies you look at, they'll have some notion of HR, they'll have some notion of marketing, advertising, supply chain, recruiting, as well as risk and compliance. So for all of these internal applications that are using Cedar, I want to, as you go back to your day jobs, think about, hey, what is the authorization system that's being used? Is it permissions and code? Is it duplication? What can I be doing to help streamline this? Talked a lot about Cedar. And the natural question is, we already have AWS IAM. So why did we end up building Cedar? That's a question that we really thought about. And I'm going to talk about what our thought process was. Now, if we look at the shared security model, there's security in the cloud and the security of the cloud. And there is a similar story for authorization that happens here. If you look at what you do today is you are running applications in the cloud. And Cedar is the authorization for things running in the cloud, while AWS IAM is the authorization of the cloud. Cedar gives your users access to their files, notes, photos, tax returns. Those are your resources, while IAM gives your applications access to AWS APIs, AWS databases, queues, and analytics. But there are similarities between the two, and we took lessons learned from IAM and incorporated them into Cedar. There are deliberate differences as well, because we designed Cedar to work for your applications instead of the AWS infrastructure. There is a lot that makes IAM and Cedar look similar. Again, that's very deliberate, but understanding the parallels and the differences is very important. There are certain key security principles that both Cedar and IAM support. Deny by default, security first. Nothing is allowed unless you explicitly grant permission. Deny trumps allow. If there is a single deny statement, access is blocked. You don't want somebody to go add an allow statement and now worry, oh, if this allow statement is added somewhere here, will suddenly access be granted? But if you add a deny statement somewhere as a security administrator, you know Jim can never access those IPA if that deny statement exists. That's an assurance you have, and it's a security principle. They both follow the PARC model, principal, action, resource, condition. And in both cases, policy order doesn't matter. All the applicable policies are evaluated. Now, we should also look at the differences between the two. In IAM, AWS is the one that enforces all IAM authorization decisions. All principles, actions, resources, and conditions are defined by AWS. AWS provides you the managed policies that are the built-in policies that allow you to do what you want to do. But in Cedar, you enforce the decisions. You define your principal, action, resource, conditions. you decide what's the nouns and verbs of your applications, what are your actions, what are your resources, and everything is simplified to a single policy type. Now, this distinction is important because while Cedar gives you the power and the security that IAM gives you, it provides you the flexibility to say, here is what authorization should look like for me. And I've talked about a lot of similarities and a lot of differences between IAM and Cedar, but there is one thing that I've actually not talked about. There's one similarity that I've not talked about, and that is related to what I call provable security of both the systems. And I'm going to tell a little story. Let me take you back to 2011. This was when AWS IAM was first launched. At the time, AWS had maybe a dozen services. Cloud adoption was just at the beginning. It was a newfangled thing, like the new buzzword. I actually think it was the moral equivalent of the AI term back then, cloud. Nobody knew what the cloud was, cloud computing. Is it real? Who knows? But one of my favorite Easter eggs in this early blog post is example names. If you look at the example names, they're actually all IAM team members from back in the day. And you see this Jim right there? You want to take a wild guess who that is? Just a wild guess? It's none other than my co-presenter, Jim, today. Jim was the leader when AWS launched IAM in 2011. Not that I'm trying to date Jim, but he's still at the forefront of authorization, talking about Cedar and MongoDB. So you got that authorization train going. But even more important, there is no Neha in that blog post. Because in 2011, I was at NASA applying formal verification technique to correctness of aerospace systems. And I joined AWS in 2016 when the cloud had expanded to hundreds of services. It had become the norm. And when I started in AWS, I started at AWS Security, where at the time my charter was, can you figure out how to use formal verification to help raise the bar on security? And one of the first things I ended up working on was how to ensure that there was no unintended access to resources. And this led to a series of innovations in applying formal verifications to security. And that's what we end up called provable security. The very first step in our provable security journey for IAM was policy analysis. In 2019, we launched IAM Access Analyzer. With one click, you could turn on IAM Access Analyzer for your entire account or your organization. It mathematically verified that your resources did not grant public access. With one click, you had mathematical assurance that your S3 bucket wasn't granting unintended public access. With one click, you had the assurance that only your trusted organizations had access to your Lambda function. The reason this was powerful was because you could leverage the power of mathematical logic without being an expert in logic or in IAM. We continued on our journey beyond analyzing policies. Customers said, hey, we need help writing these policies from the start, not just analyzing them afterwards. This led to another important advancement, policy validation. We added capabilities that helped customers like you catch syntax errors before deployment, identify overly permissive policies, fix security issues, and validate the policy structure. This was like having a security and an IAM expert looking over your shoulder while you were writing policies. Then came another major milestone, applying provable security to the IAM evaluation engine itself. This wasn't just some incremental improvement. It was fundamentally changing how we thought of security at AWS. It was the mathematical verification of the authorization engine itself. Formal proofs that the engine behaves correctly and verification of the security properties of the engine. Verification of properties such as deny does trump allow when you have so many different policy types across all the different code paths. It's not just, hey, we've tested it really rigorously. No, this is about having proved the correctness of it. And I want to take a moment to recognize this incredible journey from 2011 to 2024, the evolution of authorization of IAM and provable security AWS tells a fascinating story of innovation. Now, I want to look at Cedar in context with this entire history in mind. While IAM evolved over 13 years with AWS services, Cedar represented a fresh start for application authorization. So Cedar launched in 2023. Now, it didn't have to go through the same journey that IAM had to. From day one, Cedar launched with a proven correct version of the authorization engine. The theorems and proofs are open source. Cedar provides you a built-in validation from the start. But you notice there is an empty box here. And I'm super excited to state that today we launched policy analysis for Cedar. It provides you the ability to analyze Cedar policies in the way that you've been able to do for IAM policies. It uses the same mathematical engines under the hood that drive the innovation and power of IAM Access Analyzer and S3 Block Public Access. And the way it works is the Cedar symbolic compiler transforms Cedar policies into mathematical logic. It converts human-readable policies into formal mathematical representations. With that representations, we can prove who has access to what for your applications. And built on top of all of this is the Cedar Analysis CLI. This is the powerful tool that you can use to answer the questions. It helps you understand, what does this policy actually allow? Who can access these files? Who can delete these tax returns? It provides concrete examples of what policy outcomes are, and it helps identify unexpected combinations that's resulting. Wait, why did this end up having access? So some of you may say, wait, what's a symbolic compiler? You may not have heard of one. So I'll talk about it in the context of a traditional compiler to compare and contrast. A traditional compiler, as most of all of us see, takes a program and generates low-level code, either in assembly or bytecode, and that is optimized to run efficiently. While a symbolic compiler takes a program and generates logic or math. But you cannot run that program on your machine. But there are different engines, automated reasoning engines, that reason over symbols and variables in that program. So what does it let you do? In a traditional compiler, you can efficiently evaluate a single request with respect to a host of policies and say, hey, is access granted or denied? But with symbolic compilation, you can reason about infinite requests that could happen, that could be made to the policies to make statements such as, there is no public access to your private photos. This is important to understand, these two key differences. That is what makes the analysis feasible. That's what makes us able to say what might happen in the future. And that gives us the assurance of what will never happen given the set of policies you have. I've mentioned this before, but Cedar is open source, but not just the code, but the scientific research that goes into it. This is the semantics of how traditional compilation works for Cedar, and this is the semantics for how symbolic compilation works for analysis of Cedar policies. Before I hand off to Jim, I'm going to give you a very quick taste. I've said the word proof and logic a lot, but what does the proof actually look like? So this is a proof that our symbolic compilation is correct with respect to the concrete evaluation, which is the semantics of Cedar. This says, given a symbolic version of the concrete environment, any result we get from symbolic evaluation matches every possible concrete evaluation, many to many, and we can prove it. So this is a proof written using Lean, and again, for anybody who's interested, please go to the GitHub repo. These proofs are open source. And I'm going to put that in the context of what does it mean? What about me? How does it help you? Let's take a look at what the policy analysis does in action. This is our example that we've been using, the reinforce attendee permission. This is the policy on who can attend the sessions. The first condition needs to be that you're registered for the session, and walk-ins are allowed only if the session is in full. We could write the same policy, split into 3 different policies. You may want it, right? Like you may want it for better maintainability or for whatever reason. The first policy says you can attend if you're registered. Second policy says you can attend if walk-ins are allowed. And the third policy says you can't attend if the session is full. Okay, take a minute to look. The question you want to understand is the refactoring correct? Is the policy on the left equivalent to the policies, the combination of the policies on the right? I see some shaking their heads. You may be tempted to think the answer is yes, but the answer is no, as I saw some of you shaking your head in no. I see on the third row, very vehement no's there. The one on the left is more permissive. And the reason is that the forbid statement will not let registered attendees into the session either. Forbid trumps permit. Say, how do we fix it? We actually have to combine policies 2 and 3. We can permit walk-ins only when resource is not fully allocated. So after we make that change, is the left equivalent to the right? Yes. But the key here is like the takeaway. This was a simple example, right? But even with a simple example, we sit there trying to do the logic in our heads. Now imagine this is spread across hundreds and thousands of policies across millions of users. And even doing a simple refactoring, when it comes to authorization, can be difficult. You want to ensure you're not breaking your customers, as you want to ensure that agility is maintained, availability is maintained, correctness is maintained. And the best hope without the analysis is hopefully you've got good test coverage and you're able to catch it. But with policy analysis, you get a definitive answer. And that's the power of it. It gives you this ability to ask things like, are these policies equivalent? Does this change to my policy grant any new unintended permissions? Can this policy grant access to this resource? Will this refactoring break anything for my users? All of these questions you can ask using the CLI. And I really want to emphasize that we took a security-first approach. We prioritize security over expressiveness. If somebody comes to me and saying, hey, I'm using this X and it's more expressive, it lets me do these things that Cedar doesn't. And I'm like, yes, that's by design. I'm like, this is not a Turing complete language. That's by design. And I say other things too, but the point is, and it's you want to provide guardrails, right? You actually want to say, this is what the box in security looks like. This is where you should operate your authorization system. And which is why it was a big decision in us making this open source. We want to democratize this part of security, make it easy for people to see and use. And I'm personally very excited to see how Mongo has made Cedar part of their security and how they make security available to their customers. And with that, I'd like to introduce Jim to talk about Mongo's journey in using Cedar.
Cool. Thanks, Neha. Thanks for inviting me here. I'm excited to talk about how MongoDB has been using Cedar. So first, a little bit about MongoDB in case you don't know. It's a modern, horizontally scalable database. It's document-oriented, which can be far more flexible and easier to work with than traditional rows and columns of a relational database. It's scalable by design. It horizontally shards, so it can handle much higher availability and performance for even very large data sets. You can run it anywhere. So we have MongoDB Atlas as our managed database as a service offering. And what is interesting about that is customers can, with a few clicks of a button, run atop over 117, select from over 117 regions across AWS environments, Google's GCP environments, or Microsoft Azure environments. And that plays in, as I'll get to in a minute, is we need to be able to model access control and enforce authorization decisions across these three cloud providers and not just AWS. So that makes our needs a bit more unique, and I will talk about that. And then last, it's very integrated. So we provide a bunch of additional functionality, including things like streaming support, full text support, and vector search, all as part of Atlas. And so this plays in because now we're evolving our product space and we need an authorization engine that can model increasingly complex and new resources. So when I moved, so Neha shared, earlier I was at Amazon Web Services. And when I moved to MongoDB, one of the first things I noticed were we had a very familiar customer base. So some of you may know MongoDB originally became very popular among developers earlier on, but it really grew and matured over the years. And now over 50% of the Fortune 500 are MongoDB customers. So amongst our customers, I recognize banks, healthcare organizations, and government agencies that I had actually worked with and supported when I was at Amazon Web Services, including customers such as Wells Fargo, Intuit, Stripe, and GE Healthcare. These are very demanding customers from a security and compliance point of view. And so in my experience working with these companies taught me that security, resilience, scalability, and performance really take precedence over any new shiny features. Basically, you only earn the right to talk about new features once you've addressed their needs on things like security. So when I came to the MongoDB team, I really tried to instill that security had to be built into everything we do at MongoDB. And so I'll talk now about how, as we looked at some architectural changes we're doing, how we looked at that and why we evaluated Cedar and how that went. So first, a bit of history on the MongoDB side. So when MongoDB Atlas launched, it had role-based access control. So very similar to the lanyard example that Neha was talking about earlier. You can say, hey, this is an administrator, and they should have access to start and stop clusters. This is a developer. They should have access to write data to clusters, et cetera. And this can be very usable and has been for a number of years for our customers. It's intuitive, easy to use, understand. Oh, I'm a gray badge. I can go, or my gray badge is off, but I can go into the executive lounge or what have you, and oh, I can't go into the keynote lounge or something like that. So it's very easy for customers to get started. But over time, our most demanding security customers have even higher demands on top. They want to manage access control across many users, both human and systems. And they need to set guardrails on resources, for example, prevent any user from deploying clusters on cloud provider, let's say Azure, since we're at an AWS conference, I'll just, or require a recent TLS version for a database connections regardless of a user's role. And so that's a requirement we're hearing from our customers. And roles aren't the greatest for that. Roles also aren't a great solution for more fine-grained entitlements, which are needed in cases where, okay, well, I'm a speaker, so I should be able to get into only this room and only 15 minutes before and 15 minutes after my talk. Now you create a different role for each room and speaker and session or whatever. It can get very complex and very unwieldy and hard to manage pretty quickly. So, we basically said, hey, we got to develop something different. And, so the Atlas team, before I arrived, they took a look. They're smart people. They looked and they said, hey, some of the same symptoms that Neha shared previously, the code, the authorization logic and checks were embedded directly with the application code. So when the compliance folks come in or security folks come in and say, hey, who has access to what or prove to me or whatever, it can be pretty complex because you have to basically trace it through all the application code. It also was fairly scattered. It was implemented in multiple places across our code base. So it was imminently clear that our system had to evolve. So, the team knew right away that they had to separate out our authorization logic from the rest of the code. That was the easy part of the solution. But what to build? So they needed all the components of an authorization system, policy administration, information, decision, enforcement. But they hadn't ever tried to implement these as standalone components. But they thought it'd be hard, but they figured they could figure it out. They evaluated several third-party solutions at the time, both free solutions and paid solutions, that offered pieces of the puzzle. But as they got deeper, they ultimately concluded that none of them was really had the right mix of things, both the features and level of support that we needed. Because again, we're running databases for some of the largest banks and healthcare and enterprises in the world. So reluctantly, they proceeded to start down the path of building their own authorization solution in Java. And so we had great engineers, but hadn't done this before. So they looked out at industry, looked at prior things, including the AWS IAM access control language to kind of get inspiration of, hey, what should they do? They went and started looking at the business modeling. As Neha said, one of the first things you need to do just from a business perspective is just kind of model what are the resources, who are your principals, who should have access to what, these kinds of things. And they succeeded in building an authorization engine along with policy authoring, policy storage, which was kind of easy because we are a database, and entity storage. Our entities like objects in the system like organizations, projects, database clusters, et cetera. But as it got deeper, they could see it was going to be increasingly challenging to add more features to the engine. It was taking longer than they thought. Like no software project ever before in history took, as you got deeper, it got a little bit more complicated than they thought. So for example, areas of complexity is like, they had a new boss come in and say, hey, what about conditions or policy hierarchies or namespacing? And the more they built, the more they saw the complexity that they were going to have. And then, as I was asking about the security requirements around this, I was like, okay, how do you test all this? As Neha said, the AWS IAM team learned starting in 2011 and proven over trillions and trillions of authorization requests. This stuff is hard to get right. And originally, because the science of automated reasoning just wasn't there, AWS IAM couldn't prove it was secure by default. And so we basically, the team in the AWS IAM had to evolve and learn and add tests over time, sometimes hard-earned lessons there, right? And so coming into MongoDB, I was like, hey, I don't want to repeat that pain and learning both for us and our customers. How can we ride atop the learnings and the advancements in the technology of automated reasoning and that Cedar has built? So I asked the team to evaluate Cedar. And this was hard because our team had gotten decently far along at building a pretty good take at their own authorization engine. So they took a look at Cedar. And first they found it was a pretty good strategic match for MongoDB for a couple main reasons. First, as part of the AWS ecosystem, MongoDB inherently gains from the extensive security and automated reasoning investment and expertise that AWS invests into Cedar on an ongoing basis. And that so things like Cedar being provably secure, that investment makes it sustainable and is really an asset for us. And then as I go to our customers who are banks, governments, Fortune 500s, these kinds of things, as well as individual developers thinking of the next startup idea, of us being able to say, this is provably secure from the start, really helps earn trust with customers, right? And then knowing that AWS and Amazon, like the Kuiper example, they're using Cedar itself. It really gave us confidence that the rate of innovation was going to continue, and the more companies like MongoDB and others that we invite others to do can really spin the flywheel of this open source project. And the more we all contribute, the more things learn and grow. And then, the other thing is Cedar's open source nature mirrors MongoDB's original DNA, allowing us to use it, but actively contribute back to a growing ecosystem. And then, as I mentioned before, this is important too because we're not just modeling resources on AWS. Our customers, many choose to deploy their database clusters on AWS, but many also deploy on Azure and GCP as well, and we have to be able to model on those. And so from a developer perspective, a few positive aspects certainly immediately stood out to the team. So, Cedar is designed to be able to express any of the authorization requirements we could think of, both present and future. So it includes built-in support for conditions, as well as both role-based access control and attribute-based access control models. So really showed that, hey, as we go forward and our needs expand and our customers need us to get more advanced, Cedar can be right there with us. The other thing is, because we had started down the path of building our own policy engine, the Cedar core libraries really we were able to swap in fairly easy. Cedar's built in Rust, but AWS provides a Java bindings that made it simple for us to invoke from our existing code base, which was very nice. And then Cedar provides and enforces a simple data model and clear syntax, relieving us of some of the challenges of trying to define these things in a future-proof way. Also, as Neha was pointing out, Cedar being very readable, as policy languages go, Cedar is quite human readable, and that's going to make it easier for documentation, training, and our end customers as well. So there's a lot of benefits. So let's look at the first place where we're using the power of Cedar to address Atlas's customer needs, Atlas resource policies. So in April, we released a solution to these challenges, to some of the challenges I talked about in terms of adding guardrails, et cetera, Atlas resource policies. And they allow customers to set guardrails at the organizational level in Atlas to enforce configuration standards, maintain consistency, and prevent misconfigurations across all clusters. And so a few facts about resource policies. They're very similar in purpose to AWS's resource control policies in the sense that both are designed to express limits that apply to an entire organization. They apply to all users in that organization. And they're guardrails implemented as forbid statements using the Cedar language and enforced by Atlas, MongoDB code, at runtime for all users. They set resource policies, set hard boundaries on what configuration options are allowed. And then they do not grant access to users. For users to have access to any resources, they must be explicitly granted appropriate permissions via user policies. So now I'm going to get into a demo of how customers can use resource policies based on Cedar to achieve these goals in an environment. Now, so for this example, we're going to do a demo of implementing org-level guardrail using MongoDB Atlas resource policies. For this scenario, we're going to ensure that our DevOps team can only create Atlas database clusters, one, in Amazon Web Services Cloud, not in Azure or GCP, and then two, in two specific regions that we want as a business to operate, US East 1 and US West 2. Okay, so first we're going to create a policy. And here we're giving it a name and a description so that we'll know, the human intent as we start authoring this policy. And so as we get going, we're going to, next step after this, we're going to then author the Cedar policy to, oh, by the way, this is all within the MongoDB Atlas console. So now we're going to basically forbid, and we want to forbid all users, human users and service accounts, the ability to modify a database cluster, and the scope will be global. It's going to apply to all clusters. And then unless it's in the two regions that we trust, US East 1 and US West 2. And so we can see there the policy's been applied. And then we're going to go to the test project and create a cluster. And you can see there that the user is getting information that a resource policy may apply, which is useful because sometimes when they have issues, they don't know why. So here the user is saying, hey, I want to go US East 2 at AWS. And we see that they're forbidden because that's violating the Cedar policy that we authored in the prior screen. So now this was perhaps just unintentional. So they go back and they can go back in. And now if they choose a region that is in our list, now create the deployment. And now you can see in the bottom left-hand corner, the cluster is processing and it succeeds. So that just was a short example of Cedar in action in MongoDB Atlas to do guardrails. And so you can see these are clear declarative policies built with Cedar, enforced in Atlas, all easy to manage in the Atlas command line and UI. So, key learnings we had as a team is building an authorization system from scratch is hard. There is hidden complexity is a big issue. As Neha's little example of debugging or comparing two policies here in the room shows, even something simple can actually be more complex than you think. Like any security technology, build what you must, but defer or build upon experts wherever possible. And then, we also had the learning, we kind of happened on this just given the way of our project happened, but we invested time up front to dig deep into the entity models, actors, resources, and actions. The business modeling really is a lot of work, and getting that right is really critical to implementing something. And so what's next? Well, our customers already are using resource policies, and they're asking us for more features and enhancements to that. We're completing the engine upgrade. Currently, we have Cedar used for authorization in a number of places in code. We're basically making that to 100% to enable more work to come. Customers are asking us for more flexible policy assignment, so maybe not just at an org level, but at different parts in the hierarchy. Finer grained access control and custom roles support. And then access analysis and recommendations, as Neha hit on, customers are also asking us for things like that. And with that, I'll turn it over back to you.
Thank you, Jim. To me, I'm very fascinated. by this instance of MongoDB going through very much the same experience that we'd been talking about in previous version of in the beginning part of the talk. And I imagine, and I can bet on the fact that there's many others in your companies or others that are going through that same process. And really, the lesson learned is that, like as Jim said, building an authorization system from scratch is hard. And my corollary to that is building a policy infrastructure from scratch is also hard. Because like MongoDB, most of your businesses are probably not doing databases for a living. And it goes to, what does it mean by policy infrastructure? And what does it mean for your core business to not be databases? It's about saying, how do I centralize? How do I manage this Cedar policies in a central way? You needed to create some space, need to put them. And verified permissions is that managed service that provides you that single central location. You create, manage, evaluate, audit, and log your policies all through APIs. It makes it easy for you. It's the easy button. My analogy for this is Cedar is like the engine, and verified permission is the ready-made car powered by that engine. Mongo and Jim took that Cedar engine and built their own custom vehicle around it. But verified permission gives you an easy-to-use, ready-to-use car without needing to build one. And there are benefits. So what are the benefits you get out of it? Some are native to using verified permissions. How do you select the policies that are applicable? How do you do fast evaluation? How do you ensure that the propagation from the control plane happens to the data plane? Then there's integration benefits into AWS. We have native integrations for Cognito and API Gateway that you can just use AVP right within the rest of your AWS ecosystem. And finally, there's these standard AWS benefits, such as IAM controls. Who can create a policy store? Who can delete it? There's CloudTrail logs for the different policy changes. All the things. There's tagging. All the things you get right out of the box for an AWS service. Now, let's look at a quick demo to see what benefits you getting this car gives you. How does AVP actually integrate with some of the other services?
All right. So the setup for this demo is I have an API on API Gateway with attend and register endpoints. And to prove that this is a real API, I'll call it here. So I'll call register. It says that that action happened. I can call attend. That will happen. This is just a public API endpoint. You could call it. Please don't. But what I'm going to do now is I'm going to add verified permissions on top. So I go to the verified permissions console. I say create a new policy store. And one of the options here is to set up API Gateway with an existing identity provider. So I'll click Next. Here's my API from API Gateway, the Inforce API. That looks good. Now I pick the identity source. I can pick an external one. In this case, I'll use Amazon Cognito because I have a Cognito Reinforce attendees user pool. Next. And then in this pool, I have three groups, customers, speakers, and sponsors. So at this point, I can assign some permissions to them. So customers can attend and register. Speakers can attend but not register. And we'll say sponsors can also attend but not register. Click Next. And then finally, I can pick if I want to start authorizing now or later. I'll pick now and go. And so the first thing it does is it creates a policy store. And we'll go look at what that looks like. So here's my Amazon Verified Permissions policy store. This is kind of like the notion of a bucket in S3. It's where you put all your things. So here's where you put all your policies. In this case, I have three policies in here. The first one is the policy for the speakers group. You can see it says that these users are allowed to perform the attend action. The next policy is for the customers group. They can attend and register. And the last policy is for sponsors who can attend but not register. One other thing that's nice here is it creates a schema. So schemas are useful whenever you attach a policy, it gets validated against the schema. So in this case, based on the API Gateway setup, it created a schema for me with a user, 2 actions, and resource application. So for your application, you would eventually extend this with other types of resources like sessions or the expo or lunch. But this is enough for us here. And the other thing that it does is it attaches an authorizer in API Gateway. So if I look at my API over here under authorizers, here's this AVP authorizer that it deployed. And now if I switch back and call the register API, it should give me access denied, but there's like a 2-minute propagation delay. So we're going to see how well I've stalled for time. Not well enough, still allowed. It takes about 120 seconds for API Gateway to stop caching authorization responses. So if we give it about 10 more seconds, I think it'll give us access denied here. One last thing. So the way this is all done behind the scenes, this authorizer is deployed through CloudFormation. So there's infrastructure as code for the Lambda that's behind it, how that connects to Cognito, and how that connects to API Gateway. So you can make that part of your pipeline and deploy it in a more standard way rather than just clicking through in the console. Well, it's taking longer. That's a good sign. So now you can see it's denied. And if we pick attend instead, attend should be allowed. But that one, I must have also clicked the wrong button because that one's also getting denied. Well, it's denied by default, so. All right, back to you, Neha.
OK, thank you for the demo. And that really goes to show how we are thinking about authorization having its place in modern infrastructure, like the fundamental building blocks of your application. You need compute to run your code. You need storage to keep your data. You need databases to organize it. These pillars of modern infrastructure. And with the economies of scale, allows us to provide you authorization as an infrastructure building block. You can benefit from our scale, from our investment in it, and get enterprise-grade security. And you get to not have to reinvent the wheel for something that is not your core business. And for that, I'm super excited that we are making this enterprise-grade service available to everyone with a price reduction with for $5 per million authorization requests. We led to a 97% price reduction because we've invested a lot in making this scalable and providing it in a way that comes to you at comparable to your other infrastructure costs, and that you never have to roll your authorization again. So ending up, how do we end it? If anything, the lesson is what Jim said, building your authorization system is hard. And again, to my corollary, so is managing the whole authorization system. And you have so many interesting and exciting problems to be solving for your customers. So use Cedar and verified permissions for your authorization, whether it's your greenfield applications or your brownfield application. Get started now. There's the Cedar policy playground. It's all open source. And we have the Amazon verified permissions system. Please go fill out the session survey, how you liked. And we always love to hear feedback from our customers, what you liked about the session, what you didn't. What would you like more of? So we very much read every bit of the feedback we get. So please take the time. And I want to thank Jim again for participating and co-presenting with me. And thank you all for coming. Hope you all have a great rest of your Reinforce. Thank you.